Now in this video we'll be seeing how to calculate the value of minimum fluidization velocity by the formula, by the problematic method for a given question. The question goes like this: catalyst pellets 0.2 inches in diameter are to be fluidized with 1 lakh pounds per hour of air at 1 atmosphere at 170 degree Fahrenheit in a vertical cylindrical vessel. The density of the catalyst particles is 60 lb per feet cube and their sphericity is 0.86. If the given quantity of air is just sufficient to fluidize, then only it is called as minimum fluidization velocity. What will be the vessel diameter? And in this problem we have the vessel whose diameter has to be found by us, and then it is full of some catalyst particles whose sizes are 0.2 inches. Now inches are to be converted to meters, and then the air is entering at this huge value of pounds per hour square. This has to be converted to kg per second, and then air at 1 atmospheric pressure and 170 degree Fahrenheit. So we should also know the density of this air, and once we know the density of the air, convert this to volumetric flow rate, and then the density of the catalyst particles is 60 lb per feet cube. It has to be converted to kg per meter cube, and the sphericity is 0.86. Now let's begin how to do this problem. Now, rewriting the data, the diameter of the catalyst pellets is given by 0.2 inches. So I will convert it to meters. We know that 1 inch is equal to 2.54 centimeters. So thus I divided it to that I obtained. This is the diameter of the particles, and the mass flow rate is this value at 1 atmosphere. So now immediate my step is what? To convert this pounds per hour to kgs per second, and then find the density of the air at 1 atmosphere and 170 degree Fahrenheit. And I should also know the data of viscosity. These data are to be given in the problem to do the problem, or else it becomes very difficult. Now the volumetric flow rate of the air at 1 atmosphere 170 degree Fahrenheit is given by the formula mass flow rate of the air measured at 1 atmosphere and 170 degree Fahrenheit divided by density of the air measured at 1 atmosphere and 170 degree Fahrenheit. So substituting these values, I get it as 12.599788 kg meter cube per second, and density of this lb per hour is converted to 12.57888 kg per second, and density of the air is equal to 1. So in this formula, if you substitute, we get the same numerical here. Okay. Then viscosity of air is equal to this value, that is 0.02 centipoise, and if you convert it, it becomes divided by 1000 kg per second. And then the density of the catalyst particles is equal to 60 pound per feet cube. So this is in kg per second. Sorry, I did not mention, this will be kg per meter cube, and the sphericity will be 0.86. So now we know the basic equation is given by this one, which we already seen. Now I will substitute all the values in this. I know the 150 is as it is, viscosity of the fluid is given here in this value, and then the V bar 0m as it is written, sphericity is equal to 0.86. Then the diameter of the particle is here. Then the minimum fluidization velocity is given by this one, which has to be given in the problem. Minimum fluidization velocity is 0.45, and then I substitute here, and then in the denominator we have minimum fluidization velocity raised to 3. So with this I get the first value of this quadratic equation. In the second part, 1.75 rho is the density of the air, which is given as 1 kg per meter cube, and then V bar 0m whole square divided by 0.86, and then the diameter of the particle, and then we have only epsilon minimum raised to 3, and this is given by 9.81 into density of the particle is 9.61 and the density of the fluid is 1. So if you solve this, you get this equation, and I have written that this equation resembles a quadratic equation with the constants I have given here. A is this one, B is this one, C is this one, and X is V bar 0 m. And if you solve this quadratic equation, we get the value of the minimum fluidization velocity as 1.35. We will be neglecting the negative component of this and we take only positive value. So thus the minimum fluidization velocity is given by 1.3 meters per second. And then we know the cross-section area of the tower we are supposed to find, because I am to find the diameter of the tower. So the cross-section area of the tower, S, is given by the formula volumetric flow rate divided by the velocity. And here the velocity is minimum fluidization velocity. And here you have the volumetric flow rate, which I found in the first slide. And here this is the velocity which is plotted here. And if you do this, we get the area which is measured in meter square. And then we know that pi by 4 d square, because it is a cylindrical vessel. Pi by 4 d square is equal to this value. And finally, d is obtained as 3.45. And the answer is diameter of the vessel is equal to 3.43 meters. This is how we are going to determine the diameter of the fluidized bed by also finding the minimum fluidization velocities. With this we end this problem.